doing section 6.4, example 7. So again, we're going to take the derivative of both sides with respect to x. Last problem we had an exponential, here we've got a logarithm, so derivative of this one is going to be 3. When you have ln y, remember that the formula for taking the derivative of the natural log of some other function u is u prime over u, or du dx over u. So anyway, it's basically just whatever that is, its derivative, and goes in the top, and then the function itself goes in the bottom. So for ln y, the derivative is going to be dy dx, and then in the bottom we're going to have y. So you can actually write that as 1 over y multiplied by dy dx. Okay, and then the right side we've got a product, so derivative of the first function, 2x multiplied by the second one, plus the first one times the derivative of the second one. The derivative of the second one is going to be 4y to the third multiplied by its derivative, which is dy dx, the derivative of y, that is. Okay, so we'll clean this up a little bit. We can move the terms that have dy dx to the same side. So let's move this whole thing to the left side. We'll keep this on the left side. So we're going to have 1 over y dy dx. And then if we move this to the right side, it'll become negative, so minus. Let's put the constant in front, 4x squared y to the third dy dx. And then the terms that don't have dy dx on the right side, so this term stays there, 2x y to the fourth, and the 3 will also come over, so minus 3. Since we're actually going to be dividing this thing by something, and that something is actually going to include a 1 over y, I want to just clear all fractions here. I'm just going to multiply everything here. All the terms are going to get multiplied by y. If I multiply this term by y, the 1 over y goes away, so we'll have dy dx. If I multiply that term by y, 4x squared, we've already got 3 of them, we'll just get one more, multiplying it by y. So what I'm doing is multiplying both sides of this equation by y, and that basically just means multiply all 4 terms here by y. So this will give us 2x y to the fifth, and that one gets multiplied by y as well, so 3y. Then on the left side we can factor out the dy dx, and that's going to leave us with 1 minus 4x squared y to the fourth. That should look like a 4, not a 9. Let's make sure that's clear. So y to the fourth power, and on the right side it stays the same. So 2xy fifth minus 3y. And this was what I was talking about. If that 1 over y was still here, then that would have ended up in the denominator. We'd have had a complex fraction. Generally, we don't like to see those. So our final step here, multiply everything by the term in that parentheses there on the left side. Divide everything by that. So there is our final answer.